Hello interwebs, welcome to Let's Fix Computers. I'm doing a computer build today, or rather a rebuild. I've got a customer who's got this Acer Predator gaming PC and they want to move it into this new case they've bought, this new chassis. So what we're looking at here is kind of a conversion from a OEM off-the-shelf PC to a custom build. And there's a couple of nuances about doing this which I thought might be interesting to showcase in this process. This one I think is going to be pretty straightforward, but it's a good excuse to talk about the kind of challenges that you might face trying to do this while we go through it. There are some computers, from brands like Acer, HP, Dell, and so on, where sometimes they are just pretty much all standard components and you can move them across. Sometimes they are all completely proprietary, and by the time you have replaced everything that you need to, you may as well have just started from scratch. But also there are some like this where you have to make a couple of changes, but it is kind of possible. So let's roll the intro and we'll start having a look into this thing, and I'll show you what kind of things you might run into. So if you've got a computer like one of these and you want it to be a cool custom build, you can have a look at that with a more critical eye and decide for yourself whether that's something that might be possible for you or not. So I'll see you guys after the cut. I'm on this side of the screen now because I could put the camera slightly to my left instead of slightly to the right. And when I'm laying out a video in editing, I like to make it so I'm looking into the picture rather than away from the picture. Deal with it. Anyway, right, so here's the computer. So this is an Acer Nitro 50, and if we take the side panel off, we can have a quick look inside. So the spec of this thing doesn't blow the doors off by any stretch of the modern imagination. We've got a 12th gen Intel i5 in here. It's probably a 12600 non-K would be my guess. We've got a GTX 1650 and we've got some DDR4 memory in there. That's a Corsair kit, and 99% certain that Acer would not be using Corsair memory. So that's probably a 16 gig kit that's been put in after the fact. I'm guessing this thing originally had 8 gigs and it's been upgraded at some point. However, as DDR4, that's going to become important in a moment. Then we've also got a Wi-Fi card in there, and we've got an SSD down on the motherboard there. We've got an NVMe drive down there. There's no hard drives here, so we don't need to worry about that. So firstly, we need to have a look at this and consider what is going to be transferable and what won't be transferable. And this is where the problems are going to start for us. And already there's one that I had not considered before I started recording. So there's two main problems with this build right now. The first one is the motherboard. The eagle-eyed among you will also already have spotted that this motherboard extends all the way up to the front. And those front ports on this thing, we've got a Type-C, a Type-A, and the front audio jacks. That's actually part of the main motherboard. It extends all the way up to the front. So that means that this motherboard cannot be transferred into another case because it's not going to fit. However, you wouldn't want to use this motherboard in another case because it's only that tall and it's going to look extremely silly. So yeah, so we're going to change the motherboard. And then the other major issue we've got is the power supply. Although this power supply is an ATX form factor, again, you may have already spotted there's no 24-pin connector here. Instead, we've got an EPS cable going to the CPU, that's standard, but then there's just a 6-pin going over to the motherboard. This board is what's called a 12VO motherboard, and that's 12 volt only. And this is pretty standard issue for OEM computers these days, where what you do is instead of having all of the secondary power rails, so 5 volt, 3.3 volt, etc., in the power supply is just a 12 volt power supply, and all of the secondary rails are done on the motherboard. This is more efficient and it saves minute amounts of power, which for a custom PC, for an enthusiast PC, is completely irrelevant. However, for office computers, where you could have 1,000 of these humming away in a building, saving 1 or 2% power per computer adds up to big power savings overall. So that's when this stuff becomes relevant. There's also a discussion to be had about whether 12VO is a good thing or not, because the 24-pin ATX connector, by modern standards, is actually kind of silly and is in desperately need of an overhaul. So, 12VO might not be a bad thing, but that's a conversation for another video. Anyway, so we've got some other connectors in here as well. We've got an output from the motherboard going to some SATA connectors, and that is to power an LED strip in here. I think that's about it, actually. That's very strange. It's going to 2 SATA connectors for 2 different power strips. Wow, is that really the only way they could think of doing that? All right, fine. Whatever. It doesn't matter. Okay, so we're going to need a new motherboard, but the CPU, the cooler, the graphics card and the RAM, we can use that. We might even be able to use that wireless card as well, but we'll come back to that. If you did have an ATX motherboard in here, another thing that you'd need to check as well is, as well as whether it's 12VO or ATX, is you'd need to have a look at the front panel connectors to see if it actually has the standard pinout for front panel headers on a normal case, or power button, reset button, etc., etc. Because we're replacing the case and the motherboard on this one, that's not relevant. We're basically going to replace half of the computer here. So I think that covers all the basics. Let's strip all of this out, or everything that we're going to take, and see what we're left with, and then see how much we've actually got to replace. So I'm going to start out by just taking out these screws, and we'll get the graphics card out, we'll get the CPU out and the RAM, and the SSD as well. This stuff is going to need a good dust. I'll do that as I go. So this RAM kit is a 3600 CL18 DDR4 kit, so that's pretty nice by modern standards. It's a 16 gig kit. Intel 12th generation is compatible with DDR4 and DDR5. And in fact, I think 13th and maybe even 14th gen will do DDR4 as well. However, DDR4 motherboards for these generations are very uncommon. But for 12th gen, certainly when it first came out, it was about 50-50. DDR4 boards for 12th gen are actually fairly common, because while I think DDR5 is technically faster on 12th gen, the difference is extremely marginal. 12th gen doesn't super care about memory speed, and memory speed is kind of overrated for most applications anyway. Although, that's a very sweeping statement, and I'm not going to go into it because it's outside of the scope. But the point is, we're not super fussed that this is DDR4, but it does mean that we need to get a DDR4 motherboard. Otherwise, A, we'd have to buy new memory as well, and B, at the time of making this video, DDR5 is astronomically expensive. Obviously, if you're watching this as it comes out, then you already know. So buying new memory for this would just be a non-starter. That's not an option. And that's also, in a way, why this might be a good idea, because if you've got a computer and you want to start upgrading it, unless you're going to go and buy a DDR5 system at 4x the price for the memory, then converting your OEM build into a custom build, even if you've got to replace some parts, might be your most viable option. Finding the money for a completely new system is possibly outside the scope of a lot of people. But if you do it this way, you might end up paying more money overall for the new system because of parts replacing. And in addition to that, it's worth noting that if you'd started building from scratch, you'd have your old computer that you could sell, perhaps, and get some of your money back as well. But what this does allow you to do is spread the cost over time. So while a lot of people, they might not have the money for a completely new system from scratch, they could probably afford to spread that cost over a longer period of time and get a new system that way. So again, that kind of makes it viable. Right, we've got a 12400F here, so it's a lower power i5, but hey, it's still fine. I'm going to take that guy out. Ironically, in the current market, the 12400F is probably one of the best bang for buck gaming CPUs right now, because this thing is extremely cheap and you can get DDR4 boards for it. So it's very strange, the situation we're currently in, where a system that, a little before Christmas I would have kind of turned my nose up at is now kind of viable, which is kind of depressing. When I sneer at lower spec systems, it's not because I'm sneering on someone's poverty or something like that. I merely sneer at them because there's usually better options. However, right now, when this becomes your best option, ho-hum. It's funny how things can change your perspective. Right, our SSD, oh, that's a 1 terabyte NVMe drive. That's not bad. I was expecting it to be 512. And I'm going to steal this Wi-Fi card as well, and I'll show you what that's all about soon. Yoink. At this point, you might also want to steal the Wi-Fi antennas out of these, which are just some wires going up to the back of the case and the front of the case. I don't need to do that for this instance, but if you do need your antennas, then grab those now. So the motherboard I've got is a Asus Prime B660 Plus D4. The D4 designator means that it is a DDR4 board. And when 12th Gen first came out, there was a lot of choice for DDR4 motherboards, but they've dwindled quite a lot. And as of the time of making this video, if you want to buy a 12th Gen DDR4 board, your options are pretty thin on the ground. I actually had a lot more trouble getting hold of a suitable motherboard than I expected. There are micro ATX options all over the place. However, obviously I knew that this was going into an ATX case and that the customer's objective is to make a nice, pretty gaming PC. So sticking in a dorky little like Gigabyte DS3H or something like that, not really ideal, you know. Whereas this Asus Prime board seemed to be a good balance of trying to keep the cost down but have something that still looked reasonably nice. I'm not a massive fan of the Asus Prime series, but this one seems to fit the bill. The rear I/O on it is passable. You know, we've got 5 Type A ports and a Type C, and in addition to that, on the board itself, we've got 2 M.2 slots. We've got the DDR4 channels, and we also have another M.2 Wi-Fi slot, which is important because this means we can transfer the Wi-Fi capabilities from the old computer into this one, which is also good. Obviously, in an ideal world, I would generally recommend buying a motherboard that just has Wi-Fi anyway, because then you get good Wi-Fi and it's just easier. Wi-Fi boards are kind of the way forward in my opinion. Even if you're going to use an Ethernet cable, it's still just incredibly useful to have Wi-Fi on your computer because it means that it's easier to tether off of your phone. You get built-in Bluetooth for use with a gamepad, and just there are all kinds of random scenarios where it's just really useful to have built-in Wi-Fi. So anyway, let's get the CPU fitted to this thing. And I'll also add in the customer's SSD and the memory and the other bits and pieces. Going to need to rescue the backplate from the old computer for use with their stock cooler. Which means I have to take out this cursed motherboard. If you're really unlucky, then the cooler can be a proprietary size as well. It's uncommon, but I have seen it. I think HP specifically have a custom footprint for their coolers. Or there was just something about the HP cooler that meant that it couldn't be transferred into a custom case, which is very annoying. And all of these are solvable problems, but it's just for every proprietary component that you come across, that's another thing you have to pay to replace. And some of you might already be looking at this tiny little cooler being like, really, you're going to put that back on it? And I'm like, Yes, I am, because the customer has already paid for a new case, a new motherboard, and we're going to need a new power supply as well. So are we now going to add a new cooler onto that price as well? It's not a huge amount. It's, you know, like a decent cooler is another 20 quid, but where are you going to draw the line before you just build a new computer? And that's the point. We're trying to keep the cost down here. And it's up to you where you draw that line. Some of you might turn around and be like, no, I'd pay another £20 for an extra for the cooler. But, well, you know, that's up to you. However, this sort of one thing after another that can come up is exactly why conversions like this can become more trouble than they're worth in some instances.
It's also worth noting that sometimes a conversion like this can be forced. Let's say you own a system like this and the motherboard dies. In this scenario, there's no old system to preserve and possibly sell, so converting it to a custom build is going to net you a better and cheaper system than replacing it or just starting from scratch.
So the case that the customer has bought is this. This is a Foifkin F300. I think that's how you pronounce it. It's one of these dual chamber style cases, or fish tank style cases, whatever you want to call it. These things are kind of all the rage at the moment, and I can see why. They're not my cup of tea. I think they're too wide personally. However, they are a great way to show off the contents of your computer. You get like a cabinet style case because you get that front glass and side glass with no corner pillar, which shows off the interior of the case from a 3/4 angle really well. But because they've got these side intake fans as well, you still get really great airflow through them. And this particular one has come with a full complement of reverse bladed fans. So these side fans and the bottom fans, even though they're facing into the case, which would normally mean they are blowing out of the case because most fans blow toward the frame, as you can see, they actually have reverse blade rotors on them. So these are all configured for intake. And that's completely fine because that gives us the top and the back as the exhaust. And a high amount of positive air pressure is a pretty good way to set up most computer cases, because what we're going to do is get a lot of fresh air in directly into the graphics card and just directly into the CPU area of the case. And all of that positive pressure will just get pushed out of every other gap, which not only pushes heat out of the case, but also because it's pushing air out of all of the other tiny little gaps and holes in the case, it helps keep dust down as well. Because when you run negative air pressure, the case will be trying to suck in dust from every gap in the case, and you can't put a dust filter on every part of the case. So positive pressure tends to keep dust down as well, which is nice. It's worth noting that it doesn't work to just have fans pointing in all directions. I have seen it before where someone will have like intake, 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 and at that point it's just like, okay, you need somewhere for the air to go. Lots of intake is great, but there needs to be some direction that the air can flow in. You can't just have it all concentrate into the middle. So let's grab our motherboard and we're going to match it up. I think we need to put in an extra standoff in that corner. And I also need to fit the I/O shield for this board. Right. Now we can have a quick glance at the screw holes on the motherboard just to see if we need to move any of the other standoffs around. The most common thing that you might need to move is this one here. Occasionally you'll see this hole there instead, and you just need to move this standoff down a couple of inches. That's the usual thing that might change. If you're using a micro ATX board, you probably need to move the lower ones up. But other than that, we've got the standard 9-hole layout on this motherboard. So let's just lower that into place. And I'm looking around the back to make sure that the ports on the motherboard go into the I/O shield and we don't have any grounding pins poking into the ports. There we go. And now I'll hold that in place while I put a screw in the center. Right, now the motherboard's in, I'm just going to sort out just the cables in the case. So we've got a bunch of stuff for fans here, and we've got to find the front I/O cables, and I'm just going to roughly route them around the back to where they need to be. Also, I think I might have just screwed the motherboard down on top of this wire, so that's going to be a pain in the ass. Wow, they're really running all 6 fans off of a single header. That's bold. Right, that's all the front panel headers plugged in. So I've got my, there's a Type-C port on top of this that's gone into a 3.0 header. Then we've got some USB 2 ports. The front panel audio goes down there. And then the front panel buttons and LEDs, so power button, reset, power LED, and so on. Those all plug in down here. These guys that I call the noodly boys, they're the most awkward for a first-time builder because the connectors aren't keyed in any way. It's just pins into pins. Get your motherboard manual out, and the motherboard manual will show you the pin out diagram for this set of headers and show you where to plug things in. It's also printed in very small print on the motherboard itself in the white writing, so you can refer to that. But if you're a first-time builder, having the motherboard manual on hand to show you where all of the connectors are is absolutely invaluable, so highly recommend doing that. All right, I'm also going to plug in this fan header here and an RGB header, and this RGB header and fan header goes back to all of the case fans. And I was a little bit taken aback by this, but yeah, on this case, all 7 of these fans are daisy chained into a single fan header and RGB header, which is a bit of a bold move. It's not something that I would recommend doing, but I'm going to trust them on this. Modern motherboards, the fan headers are generally good for 2 amps. They'll take a lot more than you think, but broadly speaking, I would be uncomfortable having any more than 3 fans on a single header. But also, you know, these are low-cost fans, so, you know, these aren't deltas, you know. If you have, like, really high-power aftermarket fans that are really high flow, I would not be putting 7 fans onto a single header. You're going to blow up the header. However, for this one, these fans probably are not tornado strength, so that's fine. I'm going to trust that because we're using a decent motherboard with 2 amp headers on them, it'll be fine. But in my opinion, Fäufchen should definitely have supplied 2 of these final things, so you could have a chain of 3 and a chain of 4 or something like that. That would have been much better in my opinion. But we've only got 1 single header cable coming off of the daisy chain, so your mileage may vary. So I'm going to put in this Cooler Master 550 watt bronze power supply. These things are amazing bang for buck. This is the Master Watts something, MWE 550 bronze V2. The earlier versions of these power supplies were a bit naff. However, the V2 onwards ones are fine, basically. You know, they're not top tier or anything like that. However, people are really, really snobbish about power supplies these days, and if it's not like A tier on the PSU tier list, then everyone turns up their nose at it. But also, like, this power supply is like £40, something like that. It's actually amazingly good for how much you're paying for it. This is the kind of power supply that you want to get when you're actually on a budget and you don't have £100 to spend on a power supply. And in terms of wattage, 550 sounds low by modern standards, but it's kind of fine because you have to ask yourself what kind of computer you're putting it into. And you know, if we have a look at the computer we've got here, we've got that 12th gen i5. The 12400F is a 65 watt CPU that can boost up to 110 watt peaks. So let's pretend that it's, you know, let's pretend it's 100 watts, which is unrealistic. It's going to peak to 110, but it's not going to sustain that, not by a long shot. It's actually going to hang out in, you know, like maybe the 80s or 90s worst case scenario most of the time. So if we call it 100 watts, we've got 100 watts on our CPU. Then the graphics card, at the moment, we've got this 1650. I could power this from a potato, so we don't need to worry about this at all. But let's pretend that the customer replaces this, because they're obviously going to at some point. And let's pretend that they get a different graphics card. For the kind of budget that this customer is obviously aiming for, which is not top end, they're probably going to be aiming for maybe a mid-range card. So we're talking like a 70 class card or something like that. But also, let's take a worst case scenario. Let's pretend that they splash out and they get an 80 class card. Maybe they pick up a second-hand 4080 or a second-hand 3080 or something like that. Or, you know, maybe they get a Radeon 6800 or something like that. You know, we might start pushing 300 watts there. You know, let's pretend it's 350. So if we put in a fairly large 350 watt graphics card, and then we've got another 100 watts for the CPU, that's 450 watts. We've still got another 100 watts of overhead in here for just everything else. So, and that's a fairly realistic way to estimate your power draw. So a 550 watt is going to be absolutely fine, even if we assume they're going to get a fairly big graphics card later on down the line. And in reality, they're probably going to end up with a mid-range graphics card that's more like sort of 200, maybe 250 watts, in which case we're now looking at a 350 to 400 watt total draw of the computer. Basically, PCs don't use as much power as people think they do. Obviously, when you get up to the very top end, that can start pivoting. You know, if you're buying a Halo tier PC, you know, let's say you get a 5090 and you've got a top spec CPU. Top spec CPUs can be sucking back 250 to 300 watts, and top spec GPUs like a 5090 or something like that, those things can be looking for 600 watts, no problem whatsoever. So suddenly, you know, you're going to be needing 900 or 1,000 watts out of your power supply without too much, without too much calculation. So that's the kind of time when you need to really be thinking about how much power you're using. But for low to mid-range stuff, it doesn't actually use that much power, so we're fine. Right, we'll just screw this into the back of the case now. Now let's roughly shuffle our cables into place. In its current form, we're actually only using 2 wires out of this power supply, just the CPU and the ATX 24 pin. The current graphics card doesn't have a power connector on it, so we don't need the PCI Express power cable that we normally would. And there's no hard drives in this, we're just solid state and NVMe only. So pretty easy computer in terms of wiring this up. I'm going to come back here in a minute and just zip tie these cables in place, just so it's a bit more tidy, but we'll get everything plugged in first. There we go. I tend to go with a lighter touch with terms of cable tidying, especially on a build like this where we know that at some point the customer is going to be taking it to bits to do modifications and more upgrades. Like, you could spend half an hour meticulously zip tying all of your cable looms in place, but the moment that the customer wants to come in and get that PCI Express cable, they're going to have to cut everything out. So yeah, in my opinion, as long as everything is secured in place so it's not going to fall out of the computer, and as long as it's out of sight, that's good enough for me. Obviously, you can do as much or as little as you want. You know, if you want to do the cable pornography, you can do that. Right, so we need to put in the graphics card, and then I also need to come up with an antenna solution for the Wi-Fi, because I've put this Wi-Fi card in here, but it needs antennas on it. Because this motherboard doesn't come with Wi-Fi as standard. So for me, I've got some aftermarket antennas that I'm going to fit, but this is the point where earlier on when I said you might want to pull these antennas out from the old computer, we could put those in and we could just route those up and just, you know, tape them down somewhere. However, putting the antennas inside the computer isn't going to do very well. They're not going to get very good signal. So it'll work, but I have a better solution. So here I've got an antenna kit, and you can buy these on AliExpress for a pittance. And what we've got is a couple of Wi-Fi antennas and a PCI Express blanking plate. So this allows me to put some antennas on the back of the case. So we'll just get these guys set up. And now I can fit this to the back of the case, and then we'll just be able to screw in a couple of standard Wi-Fi antennas to the back. So if you're a local computer shop or just an amateur system builder in general, I strongly recommend having some of these on hand, and also just buy some extra Wi-Fi cards. You know, you can buy, this is an Intel BE200 Wi-Fi card, and you can buy these Wi-Fi cards plus, you know, like PCI Express adapters for them and stuff like that. You can buy this stuff cheap on AliExpress, and by having you know, some mix and match options for different Wi-Fi solutions on hand, it just means that for any given computer that you're working on, you've got some way of adding Wi-Fi to it, preferably in the most integrated way possible, without having to have a dorky PCI Express card installed unless absolutely necessary. Because as I mentioned earlier on, if you're selling a computer these days, Wi-Fi is kind of mandatory. Like, obviously there's going to be loads of gamers in chat who are just like, I will only ever use Ethernet. Sure. However, most of my customers, they just kind of assume that every computer has Wi-Fi, desktop or not. So yeah. There we go. Precious Babu little graphics card. All right, and there's our build done. So obviously that graphics card looks kind of dorky in there on its little lonesome at the moment. But the point is, now we're in a custom case with all modular parts. We've got a proper ATX motherboard and ATX power supply. And so that means that while this computer is still functionally the same spec as it was before in the little Acer case, but now everything can be upgraded and changed. So what we've created here is a platform that the customer can play with and tinker with and mod to their heart's content. So we've turned their computer from something that is kind of untouchable into something that they can now work with. And because they've got the cool case, as they put in a bigger graphics card, everything is going to fit and everything is going to look cool now. Here we go, power on at the back, and boop. Ooh, shiny. So because this motherboard has had a new CPU and memory put in it and it's starting for the first time, it might take it a moment to post. However, I've just heard the fans spool down, which is always a good sign. There we go. Wow, that posted really quick. All right, let's make sure everything looks about correct. So you can see in the top left that it's detected our CPU correctly, and we've got 16 gigs of RAM detected correctly as well. So the main thing that we're going to want to do is we want to turn on XMP. This will step our memory up to its full rated speed of 3600. And also we've got our SSD detected, so if we try and boot, it should just boot into Windows at this point. I'm also going to check our BIOS version though. We're on BIOS version 3602. This is probably going to want a BIOS update. I'm going to make sure that the computer boots up first, and then we'll come back around to do the BIOS update on it as well. So let's save and quit. So after switching on XMP, again, it might take it a moment to post. If it gets completely stuck and will not post, then you need to do a BIOS reset and try again. Cool, so it's giving us the getting devices ready. That's because the motherboard has changed, so a load of hardware has changed and Windows is reconfiguring for that. 9 times out of 10, Windows will just sort itself out because modern Windows is really resilient. However, if it gets completely stuck, just keep rebooting it until you end up in recovery mode and just boot into safe boot. If you can't get into normal mode, there is a very good chance that you'll be able to get into safe mode. Once you're in safe mode, then just reboot into normal mode and it should sort itself out. There we go. It took it a couple of restarts to get straightened out. However, now we're onto the Windows startup screen. So on another computer, we're going to search for a Prime B660 Plus D4. And this will pop up with the Asus website. And we can scroll down. This is fine, I don't care where, region doesn't matter. And we can go to support, and then driver, BIOS and firmware. And let's just grab the latest one. And this gives us this zip file. I'm going to go into the zip file and I'm going to grab this cap file here. So the file extension will vary depending on the make and model of motherboard you've got. Asus BIOSes are always cap files, capsule. So we're going to copy that and I'm just going to drop it onto a flash drive that I've got plugged in here. This is the same flash drive that I use for Windows setup, but you can drop BIOS updates onto any flash drive. Modern motherboards are completely fine with that. Super important that we safely eject the drive because with flash drives, sometimes they will spend a bit of time writing data after the dialog on the screen has already disappeared. So the reason why we safely eject is it tells the flash drive, you are about to be unplugged. Please make sure you have finished writing. So otherwise you might end up with a corrupted BIOS file. Right, I'll plug this into the back of the computer. It doesn't matter which port we plug it into. We're not doing a BIOS flashback here, we're doing a standard update. So any one of the USB ports should work fine. And now we want to find the BIOS update on this. So I'm going to go into advanced mode in the bottom right. I'm going to go over to Tools, and here we'll find Easy Flash 3 utility. So again, the BIOS update option is named differently on all different brands of motherboards. So look around for Flash Update, BIOS Update, something like that. So let's click on that, and we'll select my flash drive, which is one of these. There it is, Prime 660 plus D4. Okay, so we're going to go from versions 3602 to 3811. Begin. Now go get yourself a coffee while it does the BIOS update. We've just rebooted after finishing the update and it's just warning us that we've done a BIOS reset, which is pretty standard. So I'm going to press F1 to go into BIOS from here. And we'll need to switch on XMP again. So probably wasn't necessary to do that earlier on, but hey, at least we know that it will actually do XMP now. You can go through and check any other settings if you so desire. There's nothing that I would say is absolutely mission critical at this point. A modern BIOS will have all of the defaults set up in a way that is pretty practical. In the meantime, this thing is all done now. So that computer is ready to go. And as I mentioned earlier on, you might be looking at this going, oh, that CPU cooler looks kind of dorky and it's got a tiny graphics card in it. But again, it's not the point. The point of the exercise here is that we've converted an OEM PC that won't take any aftermarket parts into a custom build. So now it can have a new CPU cooler put in it. It can have a big graphics card put in it, and so on and so forth. So thank you everyone for watching. I hope this has provided a little bit of inspiration on things that you can do with a computer. But also do bear in mind that there are some OEM builds that are complete rabbit holes to convert. There are some systems where my genuine recommendation is don't just start again. And also consider how old the system is as well. I would not really recommend doing a conversion on anything that is older than this. This is 12th gen. If you have anything older than 12th gen, really I would be looking to build from scratch, or at least just acquire all the parts separately anyway. In the current RAM apocalypse, simply building from scratch is not a great option because of how expensive RAM is, but also there are a bunch of AM4 platforms that are 100% viable right now. I'm actually in the process of working on another system for a friend, which is going to be an AM4 system, and I've managed to bash together a gaming PC for them for relatively small amounts of money because AM4 is cheap and everywhere. So, you can do that now. Anyway, that's enough waffle. Thank you everyone for tuning in, and I'll see you next time. Bye.